Have you ever looked at a giant skyscraper or a new piece of software and just wondered, how on earth did they pull that off on time? Well, it's not magic. It's all about having a map. Today, we're going to break down two of the most powerful ways to map out any project, CPM and PERT. Let's dive in and see how they turn total chaos into a clear plan.
So here's our game plan. We'll start with the big problem these tools were designed to solve, then we'll look at the two main philosophies, CPM versus PERT, and see how one of them gets really clever about dealing with uncertainty. After that, we'll learn the basic language of these maps so we can finally hunt for the one thing every project manager is after, the critical path.
All right, first up, taming complex projects. Let's get to the heart of the fundamental challenge that every single project manager has to deal with.
I mean, how do you really do it? How do you juggle thousands of different tasks, hundreds of people, all these crazy dependencies, and somehow stick the landing on one single date? It sounds kind of impossible, doesn't it? If just one thing is late, does the whole thing just fall apart?
Well, the answer is you need a map, but not a map of a city or a country. You need a logical map, one that shows you the exact sequence of every single task and how they all connect. That's the power of what we call network analysis.
And that brings us to the two main paths you can take to build this map. You can think of it as choosing your project management philosophy. And the choice really boils down to one question. Are you dealing with something you know or something you don't?
And that's the fundamental split right there. Deterministic just means your time estimates are solid. You know them. Think, laying this stack of bricks will take 2 hours, period. But probabilistic, well, that's for when time is a big question mark. Think, inventing this new technology could take a week, or it could take a year.
This table really lays it all out. On one side, you have CPM, the critical path method. This is your go-to for projects you've done before, where things are predictable, like construction. Since you know how long things take, your main goal is to keep costs down. But on the other side, you've got PERT. This is for the wild stuff, the one-of-a-kind projects like R&D or, launching a missile. Here, time is the great unknown, so your number one goal is just trying to control the schedule itself.
So how exactly does PERT handle all that uncertainty? It doesn't just throw its hands up and guess. It actually uses some pretty clever math to turn a range of possibilities into one single trustworthy number.
See, PERT is smart. For every task, it doesn't just ask for one time estimate, it asks for 3. First, you've got the optimistic time. That's your dream scenario where everything goes perfectly. Then, the most likely time, which is, what'll probably happen. And finally, the pessimistic time. That's your Murphy's Law estimate, where everything that can go wrong does.
Then, PERT takes those 3 numbers and blends them all together using this simple but really powerful formula. You take the optimistic time, add it to 4 times the most likely time, add the pessimistic time, and then divide the whole thing by 6. What it's really doing is creating a weighted average that leans heavily on the most realistic outcome.
So why multiply that middle one, the most likely time, by 4? Well, it's pretty logical, right? It's the whole secret sauce of the formula. It gives way more importance to the realistic scenario while still letting the best and worst case scenarios have a little bit of say. It's a really smart, balanced way to land on a final estimate.
Okay, so whether you're Team CPM or Team PERT, you've got to speak the language of these network diagrams. Let's do a quick run-through of the 3 basic building blocks you'll be using to draw your project map.
First up, the activity. This is the doing part. It's the actual work. Pour concrete, write code. It takes up time and resources. And on the map, it's always an arrow.
Next is the event, which you'll also hear called a node. Now, this isn't work, it's a moment in time, a checkpoint. Concrete has been poured. Code is complete. It doesn't take any time itself, it just marks a milestone, and we draw it as a circle.
And then there's this kind of weird one, the dummy activity. Sounds strange, I know, but it's super important. Imagine you can't start putting up the drywall until both the plumbing and the electrical work are finished. A dummy activity, which we draw as a dashed arrow, connects those 2 tasks to the drywall task. It's a pure logic link that says, hey, wait for both of these to finish without adding any extra time or cost.
Okay, so we have our map, we know the language. Now it's time for the payoff, the entire reason we go through all this trouble. It's time to find this single, most important thing in any project plan, the critical path.
But to find it, we first need to understand one last concept.
It's called float, or sometimes you'll hear it called slack. All this means is wiggle room. It's the amount of time a task can be delayed without messing up the project's final deadline. Some tasks might have days or even weeks of float. Others might have none at all.
So that leads us to the million-dollar question. What does it mean when a task has absolutely no wiggle room? 0 days, 0 hours of float. What have you just found?
That's when you know you've found the critical path. It's the sequence of activities that have zero room for error. It's the absolute backbone of your entire project.
Now, here's the cool paradox that makes this so powerful. The critical path is actually the longest path through your network diagram if you add up all the times. But that longest path determines the absolute shortest time in which your project can possibly be completed. It's that chain of zero float activities where, as a manager, you have to focus all of your attention.
Let me put it as bluntly as possible. The critical path sets the minimum time for your project to finish. There is absolutely no room for error on these tasks. A one-day delay on a critical activity means a one-day delay for the whole project. End of story.
Okay, let's do a quick final check to lock this in. If you see an activity and its total float is 0, what does that mean? A, it's non-critical. B, it can be delayed a bit. C, it is critical. Or D, the project is actually ahead of schedule.
And the answer is C, of course. If you got that, you've nailed the core concept. A zero float activity is, by its very definition, critical. Any delay there is going to push back your finish date. That is the single most important thing to take away from all this.
So there you have it. You now have the keys to taming complexity. You know how to plan for the known with CPM, how to tackle the unknown with PERT, and most importantly, how to find that make-or-break sequence of tasks that defines your project's timeline. So the only question left is, what complex project are you going to map out first?